Welcome to Homework Lib.
We're going to have four different vectors in a 2D space defined by the xy plane, and we want to find the angle that each of those vectors make with respect to the positive x-axis. So the first vector that we're going to deal with is vector A, which is going to have components corresponding to -7, 2. That means that on the y-axis, we're at 2, and on the x-axis, we're at -7. To find the angle, we are going to employ the tangent function. In this case, I'm going to apply the tangent with respect to this angle theta, because then we can add up an extra 90 degrees to account for the positive x-axis. Whenever we do this, we can neglect the sign of the minus x, and we're going to get that tangent of theta will be equal to opposite caret divided by the adjacent one. In this case, in our drawing, the opposite one corresponds to the x projection, that is 7/2, and the adjacent corresponds to the y projection. So theta would be our tangent of 7/2, which is going to give us 74 degrees. Actually, 74.05 degrees. And now to find the full angle with respect to the horizontal, let's call this theta prime, we need to add up the extra 90 degrees. So we're going to end up with an angle with respect to x prime, with respect to the positive x value of 164.05 degrees. Now let's go with the next vector. The next one, all of this was for vector A. Now we're going to go with vector B. Vector B corresponds to, on the x-axis, +3, and on the y-axis, -5. So we're somewhere in this position. Now the angle that we're interested in, let's call this theta B, is going to have as opposite caret the y projection, which corresponds to -5, and on the adjacent caret corresponds the x projection, which is 3 meters. So we can go ahead and take the calculation of the tangent of theta b, because in this case, since we have a negative value, it is going to give us already the result on the third quadrant. You can also take the result without the sign and just consider that the angle should be negative with respect to the positive x-axis if we do the usual counterclockwise measurement of our angle, right? So in this case, it would be tangent of theta would be -5 divided by 3. Thus, our tangent of -5 divided by 3 is going to be equal to theta b, and theta b is equal to -59.04 degrees. Now for the third vector, that is vector c, we are going to be now in the first quadrant. Let me erase a little bit of the space that we have here. Let me label also this one. This was vector b. Now we're going to go ahead with vector c. So for vector c, we have the position corresponding to 2 and 3. So this is going to be vector c. And the angle with respect to the horizontal is going to be cy and cx as adjacent caret. So tangent of theta c would be equal to cy divided by cx. Thus, our tangent of, instead of cy, we're going to replace the value, 3/2. It's going to give us the value for theta c, which corresponds to our tangent of 1.5, which is 56.31 degrees. And for the last vector, that is going to be vector D, I'm going to put it down in black. It corresponds to the last quadrant that we have. In this case, we can go ahead and calculate this angle. This is going to be theta D. And just for simplicity, now my y projection corresponds to the opposite catet, right? So the opposite catet is going to be dy, which corresponds to 7 meters. And in the adjacent projection, over here, we're going to have dx, which is 4 meters. I'm going to put it down with absolute values because this is just the distances of the catets, and then we're going to add the result, the value of 180 degrees. So let's call this theta d prime just for making the result. So theta d prime is going to be equal to opposite catet 7 meters divided by 4. Thus theta d prime is our tangent of 7/4, which is 60.25 degrees. Now, to find the true angle, the one that we actually care about, would get theta d prime is theta d, the actual angle, is going to be equal to theta d prime plus 180 degrees, which gives us 240.25 degrees. So with that, it would be all. Thank you very much, and have a good one. Also, just for reference, this minus 59.04 degrees is the same as having 300.96 degrees, but measuring in a counterclockwise position. So that would be going from this point around here. That would be 300.96 degrees. So with that, it would be all. Remember, each of the angles is represented by the corresponding color. For A is 164.05, for B is minus 59.04 or 300.96 degrees, which are both equivalent. For C, it's going to be 56.31 degrees, and for D, it's going to be 240.25 degrees. So, have a good one.